There we go. So we are now recording. So yes, okay. So hello everybody and welcome to the March edition of the Welsh Azure user group. Thank you everybody for joining, and I'm sure we'll get a few more people through the doors now as we continue the introduction. It is the 15th of March 2023. As usual, these sessions are set up for community. There's our community group. They're the organising people behind the scenes. Myself and Matt are here in person, virtually, whatever you want to call it at the moment. Please do reach out if there's any interesting topics that you'd like us to cover or invite speakers on to talk about, or if in fact you want to do a talk yourself. Obviously, please do reach out to any of us and say hello and get involved. So tonight we've got, as always, two more fantastic speakers for you. So we've got Wolfgang Ofner on to talk about leveling up our Kubernetes scaling with KEDA, and then Seif Bassam joining us after that session to talk all around Azure Arc and building Azure outside of Azure. So yeah, two really interesting sessions. I think, Matt, you said you were working on a project with both these things. So yeah, really cool sessions. Yep. Looking forward to both of them. So yeah, we'll be kicking off fairly soon. I'll do my usual little intros and bits and pieces, but timings wise, Wolfgang will be on first in sort of 5 minutes or so, and then we'll kick in with Seif after that. So around about 40-45 minutes each session. And don't forget that we've got our quiz with Quizar, so stick around for that. Win yourself some Amazon vouchers. That'll be after Seif's session. So roughly speaking, around about 8:15 GMT. So stick around for that if you can. That would be awesome. Usual kind of housekeeping rules. Everybody, please do be courteous to each other. There are no silly questions at all. It's a learning environment. We're here to get engaged, have fun, learn something about this cloud technology that we all kind of love. But please do stay on mute unless you're invited to come off mute to speak. If the speaker asks you to come off mute, please do. But please keep an eye on your microphone status. That'd be cool. Chat is open, so as always, please get involved in the chat. Make it fun, engaging. Ask your questions in the chat, and periodically I'll interrupt if I feel we need to, or like I say, if the speaker asks you to come off and ask a question, then please do so. We always look for feedback, so at the end of the event we'll put that link up. If you can give us some feedback, it's always welcome to help to shape the next sessions. And like I say, do stick around for the quiz. So it'll be after Seif's session. And there are some Amazon vouchers up for grabs. So most importantly, be interactive, have a bit of fun with the session, get involved, use the chat, and yeah, glad to see you all here. As always, just a quick thank you to our sponsors. As you'll have noticed, we've come down to, we just got a single sponsor now, Servant, who've been fantastic. They've supported the user group since we went over to the Welsh Azure user group back about 2.5 years ago now. So big shout out to Servant, Des and the team up there in Scotland. Thanks for all the support and making these sessions kind of flow nicely with quiz prizes and hopefully beer and pizza when we get back to in person. But anyhow, I'm going to stop waffling on. It's just a little bit of an intro. Nice to see everybody here. Like I say, please do get interactive in the chat and ask your questions. But on that note, I will just hand you straight over to Wolfgang and we'll get started with the show. So Wolfgang, lovely to see you. Thanks for joining us.
Hello, everyone. Thanks for having me. Let me share my screen. So you should see my presentation now.
Got you. That's it. Got you there.
Okay, great. Then let's get started. So welcome, everyone, to my session about level up your Kubernetes scaling with KEDA. KEDA is Kubernetes event-driven architecture. And before we start, a couple sentences to myself. My name is Wolfgang Ofner. I'm a freelance cloud architect, and I'm currently located in Perth, Australia. So for me, it's past midnight. This means I hope I don't look too tired. And I focus on Azure and Microsoft technologies like .NET, and especially on Kubernetes and DevOps. And today I want to talk about an overview of the architecture and software projects from the past to the modern times. Then I want to introduce KEDA, and then I'm going to show you two demo applications. The first one is to scale your application with messages inside an Azure Service Bus, and the second one is to scale your Azure DevOps agents, which are running inside a Kubernetes cluster. At the end, I have a short conclusion, and then there's enough time for questions. But if you have any questions, ask right away or post them in the chat, and John will read them to me. So let's get back a bit in history. Back in the days, the architecture of software project was very simple. Often we had one server and a couple of clients. So there was not much to manage. There was no high availability need, no redundancy. If the server crashed, everything was offline. But back in the days, it was still so simple that it was okay. But with the higher digitalization, more demand for technology, we realized that this is not going to cut it. So we introduced load balancing, we introduced virtual machines, which made it way easier to have redundancy, high availability. We had suddenly the boom of the internet, we had many clients, and we tried to make sure that everything is running smoothly. The problem back then was that everything was still static and manually. So if we had, for example, an online shop and we saw that we had many customers coming to our online shop, we had to manually create a new VM, add it to the load balancer, make sure everything is working. And it was a tedious and expensive process. Then around 2010, the cloud provider became popular. And suddenly we had cloud service, for example, Azure App Service, and there we could do everything which we had to do by hand before automatically. So we could automatically add new machines, Azure App Services or VMs, and we could load balance and we could scale based on CPU or RAM. So we didn't have to do anything manually. This kind of worked fine. But the problem nowadays is that our software gets more and more complicated. And if you take a quick look at this picture, I don't want to go into the details, just to highlight how many parts a software has these days. So we have here, for example, a couple of Kubernetes clusters, then we have some databases, some data analytics, several storage solutions. So it's really complicated, and just scaling with CPU or RAM usage is probably not going to cut it anymore. So we had to find a better solution how to run our software to, in the end, provide a great experience for our customers or clients. And around 2015-16, Kubernetes was introduced and became popular quite quickly. And in Kubernetes, we have a resource called the horizontal pod autoscaler, or HPA. And this resource allows to scale our applications. We can scale based on CPU and or RAM usage. So for example, we can say if the CPU usage is more than 50%, add new instances to our application. But as I said, the architecture is getting more and more complicated. It's really complex. We have a lot of dependencies. We have external components, we have events. So if something happens somewhere, we have to react to it. And CPU and RAM usage is not going to help us in this case. And the events could be something happened in a database. We added messages to a service bus. Our Azure Monitor sent us an alert. We analyzed some streams. There are almost unlimited possibilities of what we can react to or what we have to process. And the horizontal pod autoscaler, it scales a deployment or stateful set. These are objects in Kubernetes. And what the HPA can do is it adds or removes pods. Pods are kind of like container. So if you don't know Kubernetes, just think of containers where your application runs inside. And as I said, the HPA can scale based on CPU usage or RAM, or it can scale also on custom metrics. But for me as a developer, this gets quite complicated quite quickly because suddenly I have to query the Kubernetes API. I have to know how Kubernetes works. I have to know how Prometheus works. And I don't really want to do this. And also it's a lot of work for the operations team. And so it's not very ideal. An example of what you can do is, for example, you can scale based on requests per second. But as I said, it's very tedious and so not an ideal solution. And here we have an overview of how the horizontal pod autoscaler can be configured. So here on the left side, we define the maximum of replicas. This means how many instances do I want to have as a maximum and as a minimum. So in this case, I want to have between 1 and 10 instances. Then I say I want to scale based on the CPU usage. So the average should be 50%. This means if it's above 50, the HPA is going to add more pods. If it's below 50, it's going to remove some pods. And here on the bottom, we have the scale target. This describes what my application is. So in this case, I have the application named custom API. And if the CPU usage is high, the custom API gets scaled out. And here you can have the behavior. Like here you have policies for the scale down. So I can configure how it should scale down. For example, I can say scale down by value. So if a scale down event is happening, it removes 4 pods at a time. And then the period, the 60 seconds, means that this only happens once in 60 seconds. Because I don't want to scale up and down all the time. I want to scale up, wait a couple minutes, see if I need more instances, and then scale up again, or just wait. And I can do the same with the percentage down here. I can say remove 10% of my applications. And all the way on the right, we have the same, just with the scale out. So we have higher numbers because if the traffic or the requests are high, we want to scale out quickly so we can serve all our requests. And then we just scale down a bit slower to make sure everything is still working. That's a great tool. But as I said, our software is so complicated today that CPU and RAM usage is not enough for scaling. And a great example is the Black Friday. If you have an online shop, for example, Amazon, and you have Black Friday, you have, I don't know, 5 times, 10 times the amount of users you usually have. So you have to scale out. But you also want to have a great customer experience. And the way these online shops do it is once you place your order, they put this order in a message queue and process it a bit later. On Amazon, you might have recognized this, that you place an order and 15 minutes later, you get an email saying your credit card got declined because it took a couple of minutes to process your order. But when we scale based on CPU or RAM usage, we can't scale if we have 100,000 messages in our queue system. So it would take maybe days to process the messages and therefore the orders. And our customers would be unhappy if they have to wait 2 weeks.
Coming.
Was there a question?
No, I think somebody just came off mute then.
Oh, okay.
Yeah.
Yeah, then I'm going to continue. Yeah, as I said, if you have so many messages in a service bus queue, we can't scale on CPU or RAM usage, and therefore we won't provide a great experience to our customers. And this was one of the reasons why KEDA, the Kubernetes event-driven autoscaling, was invented. It's an open source project. It's a CNCF project. That's the Cloud Native Computing Foundation, and it's maintained by big companies. The biggest ones are Doc Planner, Microsoft, and Red Hat. So that's already a great sign that big companies are behind it. There's a great community. It's really open source. You can attend all the meetings. So yeah, it was a great way to get started. And another great feature about KEDA is that it has built-in scaler. Right now, there's 61, and with every new version, there's new scaler coming. And if you look at the list, it's, I think, every technology you could think about. You have Kafka, so you have some messaging services. You have obviously a lot of Azure services like Azure Monitor, Azure Service Bus, but you also have databases like MongoDB, you have Redis streams. So it's almost all technologies I could think of are in there. And I have to admit, I probably haven't even used half of the technologies they support. So with KEDA, there are a couple use cases. The first one obviously is scale according to external events. As I said, if something happens in my Azure Monitor, in my database, in my service bus, I can scale. And another great feature is you can scale to zero. Scale to zero, you might know from serverless. For example, Azure Functions, they are scaled to zero. And if they get a request or an event, they scale up, run. And once they're done with the work, they scale down and you only pay for the time they actually ran. So you can recreate the serverless architecture inside your own data center if you have a Kubernetes cluster running. And you can better run or optimize the usage of your resources. An example, again, is the online shop. During the day, you usually have the customers on the shop website. So you want to have all the resources used for your website, give them a great experience. And during the night, there are usually less customers. So you can scale down the shop a bit, but you can scale up background processes. For example, you want to create shipping labels, you want to calculate loyalty points. So there's a whole bunch of background services running. And once the morning comes, these calculations are hopefully done. So they can scale down to zero and you can use all your resources for the website. The next great feature about KEDA is how to install it. It's very easy. You can do it via Helm charts, which is probably the standard way to deploy applications to Kubernetes nowadays. And the only requirement you have is that you have to have a namespace called KEDA and install it there. Otherwise, it won't work. And here, these 4 lines are everything you need to install it. So on top, you create the new namespace, and then you add the Helm chart from KEDA. Then there's an update just to make sure that you have the newest version, and then you install it. So that's everything you have to do. And once everything runs, you have 2 applications running inside the KEDA namespace. So first, there's the KEDA operator, and then there's the metric server. So these are the 2 pods up here. And they are making sure that they scale the applications accordingly. And what is to do is quite simple. And the only difference is that the operator, or also agent, scales to 0 and from 0. And the metric server takes care of scaling the rest, for example, from 1 to 5. And the way the metric server does this, it sends information to the horizontal pod autoscaler, and the horizontal pod autoscaler takes care of the scaling. So what it does, it just reuses already existing Kubernetes resources. And since you can install it that easily and it uses resources that are already inside Kubernetes, you can just add and remove KEDA without having to change your architecture or your application. So from a developer perspective, I don't even know that I have KEDA running. And from an operational perspective, I can just install KEDA and I don't have to talk to my developers. So here we have just graphical what I just said. So here we have the matrix adapter, and what this does, it just sends information to the horizontal pod autoscaler, and this then initiates the scaling if it's from 1 up or down to 1. Or it could also be, for example, from 10 pods to 5 pods, just not 0. And then on the other side, here we have the scaling to 0 and scaling to 0. So now we have installed KEDA, we have the infrastructure running, and now we have to configure our application that it can scale. Or we have to configure KEDA to scale our application, to be more precise. And to do this, we add 2 Kubernetes resources. First, the scaled object, which describes the resource or the event we want to listen to. For example, for an Azure Service Bus queue. And the second one is the trigger authentication, which contains the information how to log in or get a connection string to this resource. So the first one is the scaled object. On the left here, we have just basic Kubernetes information. The type is scaled object, and we give it a name. Then in the middle here, we have the target. So in this case, we want to scale an application that's named KEDA demo API. And down here, we configure the scaling behavior. So we want to have a minimum of 0. So we allow scaling to 0. And we want to have a maximum of 10 instances. And with the polling means we check every 30 seconds if we have to scale. And the cooldown means we wait 30 seconds after we scaled until we scale the next time. And on the right side here, we have the trigger. And there is the type Azure Service Bus. So we want to scale based on a service bus queue. And in the metadata, we configure the queue name. In this case, it's KEDA demo. And when we want to scale, so queue length 5. That's a bit confusing. This means if the queue length is greater than 5, so if you have 6 messages, we start to scale out. And the bottom is a reference to where can we find the information to authenticate to the service bus. And this authentication is the second object we here have. This is the trigger authentication. And here you have the same name that was referenced in the previous document. And what this does is it references a Kubernetes secret where it can find the connection string. So in this case, we have a Kubernetes secret that's called KEDA demo API -connection string. And inside of the secret is a key that's named Azure Service Bus _connection string. And if you look in the Kubernetes CLI, the kubectl, you can say kubectl get secrets. Then we get all secrets we have. And then we find the KEDA demo API secret. And then we can say kubectl describe secret and provide the name. And then on the bottom, you can see that there's the key from the secret we provided before. And you can find the same information if you prefer using a dashboard. You just navigate to the secret and see there the key. Okay, after all this theory, I want to show a practical demo. And I have an application, and I want to scale this application based on messages in an Azure Service Queue. So I want to scale out if I have many messages, and I want to scale down or scale to 0 if I have no messages. So I have here all the screenshots. So if you want to look at the presentation later, you can see everything I'm going to show you now. But to make it a bit more interactive, I have here the Azure portal. And as you can see, I have currently 0 messages in my queue. This means I expect that my application is not running because it's scaled to 0. So if I go to the command line and check my namespace, you can see
Wolfgang, we're still seeing your slides.
Oh, let me fix that.
That's got it.
So now you should see the Azure portal.
Yep.
Okay. What you can see here is the Azure portal. The reason is why I can show you my application is I tested it yesterday, everything worked fine. And when I tested it today morning, it didn't work, and I didn't have time to figure out why. So I have to show you the Azure portal. There we have the Azure Service Bus queue. And you can see we have currently 0 messages in the queue. So what I expect is my application to scale down to 0. This means I don't have any pods running. And if I go to the kubectl, I check the pods. You can see here 1 pod running, but that's from my ingress provider. So that's for the SL certificate. This means I have no pod of my application running currently. And what I can do next is I send a message to this queue. hope this works. And in the meantime, I can check if something is happening. So what I expect is that once the message is in the queue and KEDA sees this, that it will start a new pod of my application. So let's try it again. So now it worked. Now we have one message inside the service bus. And if you look, that KEDA already picked it up. So it said here, the container is creating. What it does now, it downloads the image and tries to run it inside the Kubernetes cluster. And in a couple seconds, we should see that the container is running. Are there in the meantime any questions while we wait?
No, none in the chat at the moment, unless anybody's got any. Pop them in the chat or come off mic.
Okay, if there are any questions, just ask anytime. And in the meantime, you can see here, we have one pod of an application running. This means it's scaled out. And what we can now simulate is that more and more messages come into the queue. So we send more messages. And this time we send 100 messages. Now we have 101 messages. And what we expect KEDA now is to scale out even further, because KEDA sees this one instance not doing the job. And we can already see we have a lot of pending. We have a couple running. And in a couple seconds, we probably have 10 created pods, because that's the maximum I defined.
I got a question.
Yeah.
So that means, for instance, if you say like the scale out rule is I have 5 messages or whatever in my message queue, does it scale for each 5 messages on when it's checking, or does it only check if the if clause, let's say the if clause is true, and then scales one instance out, or does it multiply on how many messages are in there?
That's something you can usually configure in the horizontal pod autoscaler. There you can say by how much you want to scale out. And what KEDA does, it tells the horizontal pod autoscaler to scale. It doesn't tell it by how much it should scale. So you can say, for example, only scale 4 pods at a time, because I don't want to create 10 at once. Just create 4, wait a minute, check, and then create another 4 if you have to.
Okay, thanks.
So, and if you check our applications now, you can see we have all 10 running. So that's the maximum I configured. And now our application can process the orders or whatever is in the queue. And now we can also simulate that all these messages were processed. So we have no messages in the queue left. And in like 1.5 minutes, oh, there it's already, KEDA already saw what's happening, and it's terminating all the pods. And our application is not running anymore. We don't need any resources in the Kubernetes cluster, and we can use the resources for something else, for example, our website. Usually you have the scaling interval of 5 minutes, and KEDA also caches some of the values. So in my last couple of presentations, this example never worked because I tried to scale up and down too fast. So today we were lucky, but it's unrealistic to scale up and down every couple of seconds, but also too long for a presentation to wait a couple minutes. And as I said, I have screenshots for everything I just showed you, and also here with the Swagger UI, which does the same as the Azure portal. And something that's interesting, what you can see here is something that happened today, that you have a couple pods running and a couple pods pending. And that's something I wanted to remember. I'm going to talk about in 1 minute. So here's exactly the same, that we scale down to 0. And something that's also important to remember, if you scale down to 0, your application is not available. So if you have a website, for example, nobody can reach your website and it can't scale up. So only use KEDA for like processing jobs. As I said, processing messages from a queue. And what's probably also very interesting is you want to have logs, what's going on inside your Kubernetes cluster. And also you want to see how often or how much does the scale events happen. So you can maybe optimize the size of your Kubernetes nodes. Maybe you need bigger ones, maybe you need smaller ones, save some money. And KEDA provides this. So the KEDA operator writes messages, what it's scaling and from what amount to which amount. So if you look at the output, you can see that the first line, it's the scale target, is the KEDA demo API. So I know what application it scaled, and it scaled from the original replica count. So it was 6 to 0. So we can see it scaled down to 0. And in the last line, you see the same application scaled from 0 to 1. And so I can analyze what's going on in the cluster. So then every great technology has usually some limitations or drawbacks. And the ones for KEDA are actually kind of simple. The first one is if the scaler is not available. So as I said, there's 61 built-in scaler. So it's quite unlikely if a scaler for your technology is not available. But if it's the case, you can either create a ticket on GitHub, or you could implement the scaler yourself. Since everything is open source, this would be possible, and create a pull request and have it in the next version. And the second thing is what I said before, that some pods were running while some pods were not starting, is when the cluster runs out of resources. That's not a KEDA specific problem, but if I scale up from 0 to 10 instances, it's possible that my cluster doesn't have enough resources. And you can also see it here on the screenshot. That here on the left, you can see here we have 2 instances running, but the 8 other ones are not running. And if we check, for example, the first one, why it's not running, we see the error message that insufficient CPU. So our Kubernetes node doesn't have enough resources to start this application. If you're using Azure, you have the Azure Cluster Autoscaler, which is the same as the pod autoscaler just for the whole cluster. So it adds new nodes, but it can be costly. So if you add more and more nodes, you just pay more and more. So you should think about before using the scaling. Just don't say, I want to have 100 instances because I know this is going to work. Just analyze how many resources you will need to have happy customers and define a limit. In my case, it was 10, but the cluster couldn't handle it. So I have to analyze, do I really need the 10? If yes, I have to add more resources to the cluster, or maybe 5 is also enough. Then I reconfigure my application to 5. And as always, if you run applications, monitor what's going on, monitor the cluster, so you hopefully never run out of resources. And the second demo I want to show you is how to use KEDA with Azure DevOps agents. So you can run your self-hosted Azure DevOps agent inside a Kubernetes cluster. So what I want to do today is we're going to prepare Azure DevOps so you can run new agents. Then we're going to build the Docker image for the DevOps agent. We're going to test it on my machine. And afterwards, we deploy it to Kubernetes, test it again, and then we add KEDA, so we can use KEDA to scale depending on the pipeline queue. Since we don't have too much time left, I'm just going to show you some screenshots and talk to them. So the first thing is we have to create a personal access token so that our DevOps agent can access our Azure DevOps server. That's the same on GitHub. You go to the settings, there you have personal access token, add a new one, and in Azure DevOps, you have to give it the permission, read and manage the agent pools. Then after you clicked on create, it shows you the token just once. I think that's also everywhere the same. So make sure that you copy the token, because if you close the window, the token is lost. The next, I want to create a new agent pool. So you go back to the settings, and on the left side, you click on agent pools and add a new pool. And this pool is a self-hosted pool. And you just give it a name. In my case, I gave it here a very simple name, just KEDA. So the Azure DevOps server is ready. And next up, we have to create the agent and start the agent locally. So therefore, we have a Docker file and a start.ch file. That's a file that's provided by Microsoft that takes care of running the agent. So we just download this one and have it in our folder. I also have a link to my GitHub repository. So if you want to try it out later, you will find it there. And one thing that's very important, if you're using Windows, you have to make sure that the start.ch file is saved with LF end of file endings. If you don't do it and you use the Windows file ending, it will say that this file is not available. And I don't want to admit how much time this already cost me trying to figure out what's the problem. And in the Docker file, since you have all the code, you can install whatever you want. So for example, I took the standard Docker file from Microsoft and I added the wget program on top here. And then I added down here the .NET SDK for version 6 and 7. So my DevOps agent is capable of building .NET 6 and 7 applications. So there you can add whatever your application needs. Could be, I don't know, Java, Node, whatever. You're free to install everything. Next up, I just make a normal Docker build and you provide a name. In this case, the ADO agent KEDA name. And you can see here, it took quite some time. So on one hand, my internet connection here is quite slow and the image is quite big. I think it's 2.5 gigabytes. So it might take some time to build it. But once you build the image, you can start it locally and test if everything works. And therefore, you need free information from the Azure DevOps server. The personal access token, which we created before, the pool name, also the one we created before, and the URL to your Azure DevOps server. And then you can say a Docker run, and you provide the variables, for example, the URL up here, then the token, and the pool name. And additionally, you have to provide a name for your agent. There you can select whatever you want. I'm very creatively just call it agent. And for the Docker, you just say what image you want to start. And there you can see that it's starting up. It takes a couple seconds. It connects to the Azure DevOps server, and then it just waits until you run a pipeline. And to test that everything is working, I have an Azure DevOps pipeline, and all you have to do is on top, you tell it to use the pool where you just installed the Azure DevOps agent. And then I have a very simple task, just a bash script that does nothing, just to confirm that it's running. Then when you run this pipeline, it takes just a couple seconds. Everything is green, so it looks like it worked. And if you look at the output of your console, you also see that something happened. So when it was starting up, the agent was added. It connected to the server, and here you can see that it's running the job. And also after it finished, it shut down automatically. So it means that it's always starting a new agent, and once it's finished, it's shutting down. So the next step is add a tag and push it to a container registry. In my case, I pushed it to Docker Hub. So if you want, you can just download the image from there. Usually I use the Azure Container Registry just because the connection is a bit faster if I run it in an Azure Kubernetes service, but there you can use whatever you prefer. And the next step is to configure the agent to run inside the Kubernetes cluster. So first we have to create a Kubernetes secret. And in Kubernetes, secrets are base 64 encoded. So you take the personal access token from before, encode it base 64 and paste it in there. And if you want to try my code later, I always made a comment here. So you know which values you have to replace with your own. The next one is a Kubernetes deployment for the agent. And there we provide the same information as before. So we have here the Docker Hub image, the one we just pushed. Then we have the URL, the name of the pool, and the reference to the secret which we just created. And to test, I also created a new namespace so I can delete it easier after I tested everything. I deploy the application there. And as you can see, it almost took 1.5 minutes to download the image and run it. And after that, it was running in the Kubernetes cluster. And when I go back to my Azure DevOps server, I can see that I have one agent running. That's the one I just deployed inside Kubernetes. But what you have to do now is you turn off this agent. And the reason is that Azure DevOps needs at least one agent inside the agent pool to start a pipeline. That's just something Azure DevOps specific you have to know. If there's no agent, Azure DevOps can't start or can't use this pool, and therefore it won't be able to scale with KEDA. So once we have done this, we deploy the KEDA scale job. And this object takes care of scaling the Azure DevOps agents we need. So again, we provide the image, that's the same as before. The URL is the same as before, the secret to the access token. And what we also need here is, down here, we need the pool ID. So I've lost my mouse, but here it is. On top here, we provide the name, but we also have to provide the pool ID. And either you look in the URL of the pool when you're there, or you can also use this URL here. You just have to replace the organization with your organization name, and then you will also get all agent pools you have, and you can find the ID there. So once you have done this, we deploy it. And then we are ready to test the scaling of our Azure DevOps agents. So I go back to my pipeline, and I have a couple jobs there now. And they're very simple. And all they do is just sleep for 5 minutes. So it's basically simulating that I have a pipeline. And in total, I have 5 jobs. So I expect KEDA to scale 5 agents. And if I start this pipeline, wait a couple seconds, I can see here that I have 5 Azure DevOps agents running. But if I go to my Azure DevOps pipeline, I can see here that I have 3 queued and 2 running, although I have 5 agents. And that's a constraint due to my licensing. I only have the licensing for 2 concurrent jobs, and that's also a factor. If you scale up to 5, it doesn't mean that you're actually using all the 5 agents. And you might already have heard there's some limitations with Azure DevOps. As I said, you have to have at least 1 agent in your agent pool, even if it's not active. You have to make sure of your licensing. You can only use as many parallel jobs as you have licenses. And yeah, scale to 0 is also only possible if you have 1 agent inside your agent pool. And there are also a couple of limitations with KEDA. For example, if you cancel your Azure DevOps pipeline, the pods will just continue running. And also, after the pipeline is finished, KEDA does not remove the pods. So they just stay there as completed. And also Azure DevOps just shows all the pods as offline after the scale down. And the solution for this would be just to have another pipeline or a Kubernetes cron job to run every hour or once a day, just to clean up. So now to the conclusion. Can you use KEDA in production? Should you use it? My answer is definitely, especially since, I think last year, Microsoft is using it itself for the Azure Container Apps. And if Microsoft is using it for one of the most popular services, this gives me very high confidence that I can use it for my services or applications. And it also used it for the Azure App Service in the Azure Arc. Azure Arc is another great tool, which we're going to hear in a couple of minutes. And also when you look at KEDA, it was first published at the end of 2019. Currently, we're at version 2.10. It has over 6,000 stars at GitHub. It has a great community. So there's probably no reason not to use it. And for everyone interested, I have all my applications on GitHub, so you can try them out. I have a couple links, and you have here a QR code to the presentation. And you can find me on socials, LinkedIn or Twitter. If you have any message, any question, just message me. And I hope we have 1 or 2 minutes for questions if there are any.
That was perfect. No, thank you, Wolfgang. I'm just scrolling back up now to make sure I haven't missed anything in the chat. So I know, Matt, you've been tackling a few of the questions as we go. Are there any questions in the chat that I might have missed? I'm just scrolling up now. Anybody wants to come off mute to ask a question, or are we all good? No, I think we're all good. No, Wolfgang, that was fantastic. Certainly like me with KEDA. It's a great talk there. So thank you very much for coming along at such an unearthly hour. Great session.
Yeah, again, thanks for having me.
No, really appreciate it. I would say stick around for the quiz, but I'm pretty sure you're going to want to get some sleep fairly soon. So, Wolfgang, really appreciate that. Thanks so much for giving up your time. If everybody wants to show their appreciation, that would be awesome. There we go. Little emoticons happening. Really appreciate that. We got your details. Everybody's got your details. So look out for some more followers on the socials now, Wolfgang.
Yeah, great. Thanks, everyone.
Really appreciate that. Thanks a lot. I'll speak to you soon.
Thanks a lot, Wolfgang.
Super duper. Okie dokie. Well, we'll move straight along. What we're looking at, 20 past 7. Yeah, we'll move straight into Seif's session. If you're there, sir, the floor is yours.
Yes, I'm here. Do you hear me okay?
Yeah, got you loud and clear.
Perfect. So hello, everyone. Glad to be here today with you. Today I'm going to talk about a very interesting topic, and Wolfgang has teased a little bit about it at the end of his slides, which is Azure Arc. So today I'm going to talk how to build Azure outside of Azure. And you see at the bottom lots of familiar Azure services. So I'm not going to cover all of this because we're going to need maybe 4 more hours, but I'm just going to focus on some of the generally available or some of the most common services that Azure Arc enables. So before I dive into it, just a quick intro about myself. So I'm a senior cloud solution architect at Microsoft, been there for about 5 years. And before that, I've been in the IT industry for about 10 or 11 years. I'm also part of a team called the Azure Arc Jumpstart team, and I'm going to talk about that at the end and show you what this project is all about. And you can find me in different places. So on Twitter, I have my own blog, on LinkedIn, and I recently started a YouTube channel with some Azure tips and tricks. So definitely check that out. So before we start with the interesting things, let's first start what problems does Azure Arc solve? Why does Azure Arc exist? So lots of customers have complained about different challenges that they're facing that are preventing them from totally migrating to Azure. So moving to the cloud is the North Star. It's the ultimate goal. But when it comes to reality, lots of customers are not there yet, or they have some scenarios where they cannot simply move to the cloud. And in those scenarios, the most customers would lose something. So they lose agility, they lose the power of the cloud, they use security capabilities or monitoring capabilities, or they use the agility that they can provide to their developers who are already using the cloud and already using tools on different cloud platforms, not just Microsoft. So we hear a lot of challenges like compliance. So a lot of customers that have data sovereignty requirements, maybe they have very critical data that simply cannot leave their premises, and they simply cannot move those workloads to the cloud. Latency is another thing. So maybe customers have remote branches with air-gapped platforms or solutions where they need to have compute power at this remote location. So hosting those resources to the cloud is simply not an option. And definitely regulation. So again, some customers have country-specific or even industry-specific regulations where, an example, the database layer must remain on premises. They can move the applications to the cloud, but the database layer definitely needs to be on premises. So to talk about this in a more visual way, so if you look here at the right, you can see the type of infrastructures that customers have. So you would see Azure, you would see on-premises, you would see AWS, GCP, and a whole lot of other platforms where customers are. So most customers usually now have a multi-cloud strategy to avoid vendor lock-in and other considerations. And some customers as well would look at hosting their own data center. Some customers would use partner data center. Some customers would have edge locations where they're hosting their applications on small IoT devices or small form factor hardware in remote locations, in submarines, in the forest or something. So it's very diverse in terms of the infrastructure. And on top of all of that, you'd find thousands and thousands of apps. And again, those apps can live on virtual machines, on containers. They can be databases. They can be serverless APIs, whatever. So having this huge amount of diversity is a good thing, but it introduces some challenges. So a customer would ask, how do I make sure to secure all of this from a single place? Customers would, for example, if they're operating at Azure and on their premises and maybe on AWS, they would have to use a different tool for each platform. So Microsoft has Defender for Cloud, AWS maybe has another solution, and monitoring and everything else. So it requires a huge amount of upskilling of their employees to be able to have this single pane of glass across all of their infrastructure. Another thing is enabling their developers, or the agility that the developers have. So developers, the best thing to provide to developers is to have them focus on their code and not forcing them to learn different cloud providers and different tools. All the developers needs to learn is their tools, and this is where they shine and provide value to their businesses. And of course, regulatory requirements. So imagine that we're talking about a bank that needs to comply with maybe the PCI regulation. So how do you apply those controls? How do you monitor the compliance across all of what you see on the slides now, across clouds, across infrastructure, across types of applications? It's definitely a very, very hard task. So with that said, what Azure Arc does is that it provides this single control plane on top of everything that I just discussed. So single control plane on Azure. I go to the Azure portal. I can see, I can monitor, I can govern, I can manage everything that I have, regardless where it lives. So it can live, I have some resources living on Azure, but I can also manage them from AWS or from Oracle Cloud, and I can use the same tools that I use in Azure and the same tools that my IT team is familiar with, like Azure Monitor, and I can monitor the CPU of all of my virtual machines from just the Azure portal. Similarly, in terms of security, I can simply apply the PCI regulation from Defender for Cloud, and then I have a dashboard to tell me the compliance percentage of my infrastructure, regardless where it lives. So this is the power of Azure Arc. It gives you this single control plane. It gives you Azure's control plane sitting on top of any infrastructure that you have. Another important aspect or perspective of this is not just IT, but if we talk about developers as well, you would see here that developers, again, focusing on their tools and experiences. And if we're just talking about Azure, developers would have the cloud infrastructure and the services, and on the top of the layer, you would have security, operational, and governance. So when you introduce other clouds, you're going to find that this stack would be duplicated. So in AWS, they have their infrastructure, they have their services, they have their security and governance operations. So if you have footprint in 3 clouds, then you're going to have this stack duplicated 3 times, and the developers would have to learn this 3 times. So with Azure Arc, what you provide to your developers is that they still use the same tools, the same experiences that they have. They don't need to learn something new. And Azure Arc allows them to deploy those applications, manage those applications, secure those applications, regardless of the infrastructure. So in different clouds, on IoT devices, in branch offices, et cetera, et cetera. So with that said, this might be a little bit philosophical. So let's drill down to it, and let's see how this actually works in terms of actual services that Azure Arc provides. So Azure Arc provides 2 categories of solutions or services. So we have Arc-enabled infrastructure and Arc-enabled services. So Arc-enabled infrastructure is you already have resources. So you have servers, Windows or Linux, you have Kubernetes clusters, you have SQL Server deployed, again, anywhere. And you'd like to be able to bring the Azure capabilities to it. You'd like to get the Azure control plane on top of those resources without leaving your data center or your other cloud provider. So you'd like to use Azure Policy, you'd like to use automation, Defender, etc. So with this, Azure projects those servers into the Azure portal so that you can see them as a first-party product or a first-party resource in Azure and treat it as you treat your Azure virtual machines or AKS clusters or Azure SQL database. So this is the first category of services. The second category is the other way around. So say that you're already using Azure, you're using Azure Functions, or you're using Azure SQL managed instance, and you'd like to use this, but on your infrastructure. You don't want to host your database workloads there, but you need this. You need the goodness of the managed solution, the Azure managed solution on-prem. So with Arc-enabled services, you're able to take those services that you see on top and deploy them outside of Azure. So you can actually take Azure Functions and deploy them in AWS, or you can take Azure Machine Learning and deploy it on an IoT device in a remote branch and get the same, to be accurate, not entirely the same. Of course, there are some limitations, but you get a very familiar or a very standard experience for the Azure PaaS services, but you get this outside of Azure. So to summarize, any infrastructure anywhere, servers, Kubernetes clusters, SQL, data services, app services, and on top of that, you get the whole ARM or Azure Resource Manager control plane on top of that. So today I'm just conscious of time. I'm just going to focus on the first three scenarios that allows developers and allows organizations to innovate anywhere with Azure Arc. Let me start first with the develop cloud native and operate anywhere story. So with Azure Arc, I've mentioned we have Kubernetes clusters, and Kubernetes is considered the operating system of the cloud, the new operating system of the cloud. And this is where you would enable your developers to develop cloud native solutions. And nowadays, AKS is Microsoft hero product in terms of Kubernetes. And now you can deploy AKS absolutely everywhere. You have AKS on Azure Stack HCI. You have AKS on Windows servers. You have AKS Edge Essentials, which can be deployed on IoT devices that maybe have 4 gigs of RAM. You can deploy it on Windows 10, Windows 11, IoT. So you can have AKS absolutely everywhere. And at the same time, you might have another flavor of Kubernetes. You might have Red Hat OpenShift. You might have GKE or EKS from Amazon. So again, we want the developers to just this be transparent to them. We don't want them to focus on the infrastructure. All we need them to do is to build their cloud native solutions to any Kubernetes anywhere. Alongside the apps, of course, there needs to be the data. I'm going to talk about the data, but in a later section. But in terms of cloud native and what Arc provides is that it allows you to Arc enable any Kubernetes cluster that you have, whether it's AKS outside of Azure or, again, any other supported Kubernetes distribution. And it adds to it some capabilities. The top capabilities that I'm going to talk about in demo today is GitOps. And I'm going to explain what that is for those who are not familiar with the term. You get Azure policy, so you're able to consistently assess and manage your Kubernetes clusters anywhere. So you can say any image that is found to be vulnerable through Defender for Cloud, do not deploy it. So if I'm a developer and I'm trying to deploy to an OpenShift cluster on-prem, and I try to deploy this image, Azure policy that is enabled through Azure Arc is going to stop me from deploying this, and I'm going to get an error when I'm running the kubectl apply command. Azure policy is a very powerful solution. You apply the policy, and regardless of what type of Kubernetes cluster that you have, AKS or any other Kubernetes cluster that is Arc enabled, you're going to get this consistent level of governance. Of course, security and monitoring is something that Azure Arc brings to your Kubernetes cluster. So you get Defender for containers. You can deploy it anywhere. So you get those alerts, continuous recommendations, and other capabilities that Defender for containers brings. And again, you don't have to be in Azure to get those kind of capabilities. And finally, you get Azure Monitor for containers. Again, it's a very, very powerful solution. It allows you to monitor your nodes, monitor your pods, monitor your containers, and even get logs from within the containers, all from the Azure portal. So to give you a high-level overview, this is how it looks like. So if you look at the bottom, you would see different types of infrastructure and different types of Kubernetes flavors. And the first step is to Arc enable those clusters. And it's a very simple command. There are some pods that gets deployed on top of your clusters, and those contain the agent that Arc enable your Kubernetes cluster. And once you do this, then you get access to this ARM or Azure Resource Manager control plane, and you get access to all of those cool capabilities that you might be already using on Azure, or you'd like to use them for a specific use case. Another capability that this brings is that how you interface with your clusters. You can't do this now using the normal channels like Azure CLI, PowerShell. You can deploy them using Terraform or Bicep because, again, they are considered an ARM resource, a first-party Azure resource. So you get all of those capabilities. So I can go and deploy an OpenShift cluster, an Arc-enabled Kubernetes cluster. I can go and deploy an Azure function on top of it. Just using Terraform or just using Bicep or an ARM template. So again, this brings lots of power to your developers and also to the SREs. So again, some of the highlight capabilities, we already talked about monitor and security. Another set of capabilities that are very powerful is Azure Active Directory integration. So again, you might have Kubernetes clusters outside of Azure, but you're a heavy user of Azure Active Directory. You have all your groups and roles hierarchy configured in Azure AD, and you maybe would like to extend this to your Kubernetes cluster that lives on premises or that lives on AWS. So Arc enables this type of integration. So it allows you to do role assignments, define specific roles, to have specific access to even namespaces within the Kubernetes cluster, and you can also create custom roles. So it's very, very powerful, and it can elevate your normal Kubernetes RBAC model. You can use Azure AD. Cluster Connect is also another very cool capability. So it allows you to connect to your Kubernetes clusters without any inbound connection. So once it's Arc enabled, the Arc agent or the Arc pods that lives on your cluster allows you to channel or proxy this kind of connection from anywhere. So as long as you have the right RBAC permissions, then you can connect to the cluster, and no inbound ports needs to be open on your firewall. So it's a very secure connection, and it allows you from Cloud Shell, from PowerShell, from Azure CLI to initiate this connection through the Arc agent and connect to your Kubernetes cluster, maybe to debug or deploy something depending on your needs. The other very, very important capability, which unlocks the other services that I was talking about, like Azure Functions, container apps, app services, is custom locations. So if you've played with Azure before or deployed any Azure resource before, you need to select a region or a location to deploy this, and you have East US, West Europe, etc., etc. So with custom locations, once you have an Arc-enabled Kubernetes cluster, you can create a custom location on top of this cluster and give it a name. And then when you go to the Azure portal and try to deploy an Azure function, next to the regions that Azure have, like East US, West US, UK South, you're going to get this custom location. So as a developer, when I'm trying to deploy a resource, I know I need to deploy it on premises due to some regulations. So instead of selecting UK South, I'm going to select my custom location, which is the OpenShift Kubernetes cluster that lies within our data center. So this is the doorway to the Azure PaaS services that you can deploy. So SQL managed instance, Azure Functions, Azure Web Apps, etc., etc. The last thing I'm going to talk about before jumping to my first demo is GitOps. So for those who've not heard the term, GitOps is a way to manage your Kubernetes cluster through Git. So it allows you to manage all of the configuration, all of the applications that you'd like to deploy in your clusters, and host them in Git. So maybe we're going to use GitHub in the demo. So on GitHub, I have some YAML files where I define some RBAC roles for my clusters, the applications and how I would like them configured. And then I do this sort of handshake between the cluster and this Git repository so that my developers or my cluster admins can track the changes, track changes to the Kubernetes cluster configuration or their applications through Git, so that I don't need to connect to the cluster each time and deploy this manually. All I need to do is go through the normal Git flow and submit pull requests and do changes, and then automatically Arc through GitOps and Flux is going to do this handshake, and it's going to refresh my cluster state. So it's a very cool way to manage a fleet of Kubernetes clusters that you have and have a consistent deployment of that. So Azure Arc supercharged that is that it allows you to do this on a larger scale. So not just your on-prem clusters, but again, maybe your AKS clusters, maybe your EKS or GKA clusters, or any clusters even on your Windows machine. So I'm going to demo this in just a sec to show you how powerful that is. Yeah, now let's go to the demo and let's see how this would work. So I'm going to jump into the Azure portal, and this is the Azure Arc Center. Here you're going to find all of the Azure Arc services that are available. So I'm just going to focus on Kubernetes clusters. So here I have deployed 2 Kubernetes clusters using Rancher Kubernetes distribution, and other one using Cluster API. So those are not AKS clusters. You can have any type of Kubernetes cluster, again, that can reside anywhere. If I go to my first cluster, my CAPI cluster, as I call it, and I'm going to go to extensions. Here you're going to find a set of extensions that get deployed on top of the cluster, and I've deployed all of them. They're not deployed by default. So here you can see Defender for containers, Azure Monitor, Azure Policy, Flux, Open Service Mesh, and Key Vault. So every extension unlocks additional capabilities to my cluster. So for example, I can use Key Vault to store my secrets, my Kubernetes secrets. I can use it to store my certificates. I can use Azure Policy, as I mentioned, to govern my containers. I can use my clusters, and I can use Azure Monitor to monitor my cluster. So all of this is unlocked through extensions. So this allows me to, from a single place, deploy those extensions and get the full list of capabilities. So here I'm showing you Azure Monitor for containers, and just by installing the extension, I can get very cool metrics around the node utilization, the number of active pods. I can see the nodes that I have in this cluster, and I can see their performance, the trend of their performance. I can go a bit deeper to look at the different processes that are running on top of them, and the pods and the containers that are running within them. And I can also see the containers, and I can even get the logs from those containers. So if I select this Telegraph container, I'm going to get some information around it, and I can also, if I go to view log analytics, I'm going to get the logs from within the container. So it's a very fast way to troubleshoot. And similarly, we saw Defender for Cloud. So if I go to my security pane, again, I just deployed this before the call, so I don't have any recommendations. But as Defender picks it up, you're going to find some security recommendation and maybe some security alerts for my Kubernetes cluster. The one thing that I wanted to show you is GitOps and Open Service Mesh, because they are very, very cool. So you can see here I've deployed some GitOps configuration. I've deployed some applications, and I've deployed also some RBAC permissions to govern my my cluster. So if I click on this Hello Arc one, you can see that I have this configured on a GitHub repository on my repo, and this is just a sample application. Let me very quickly open this to show you how it would look like. So what I have here is that I have an application that is deployed. It's a simple Hello World application, and I have this deployed on my Arc-enabled Kubernetes cluster through GitOps. So let me just, okay. This is my GitHub repository. This is my Hello Arc application. I'm just going to show you. It's a simple YAML file, and it has a message called "Welcome to Azure Arc GitOps demo." What I'm going to do is that I'm going to jump to my Kubernetes cluster, and I'm going to open the app to show you how it looks like. So as you can see, it's a very simple app. It says "Welcome to Azure Arc GitOps demo." To show you the developer flow, what I'm going to do is that I have a lot of windows open. So I'm going to change this message in my GitHub repo, and I'm going to show you what happens on my Arc-enabled Kubernetes cluster. So here, what I'm going to do is that I'm going to just see the pods that are available here. I have 3 pods for the app, and all I'm going to do is simply edit this file and say, welcome to the, I don't know why I cannot type, user group, and I'm going to commit. So just giving it a couple of seconds, you're going to see that I'm going to get new containers being deployed. And as my app refreshes, you're going to see that this message is going to change based what I've done on GitHub. So as a developer, I don't care where the Kubernetes cluster is. I only care that I'm working with Git, I'm working on GitHub, my application is hosted there. This is what I need to worry about. I don't need to learn where the Kubernetes cluster is located. So as you can see, my application has got updated. And again, I've not touched anything in Kubernetes. I've just worked with GitOps and GitHub. So this is the first demo that I wanted to show you. Another demo that I wanted to show you is, let me jump back here, is Open Service Mesh. So Open Service Mesh is a concept in Kubernetes, and it's not a Microsoft thing, but it's a concept in Kubernetes that allow you to manage policies on your Kubernetes cluster and networking. So what I've done here is that, again, I have in the same repo, I have some configuration for Open Service Mesh that allows me to split the traffic between 2 versions of an application. So I have an application called Bookstore. I have version 1 and I have version 2, and I have 100% of my traffic going to V1. Now I want to launch V2, so I'm going to split the traffic again through GitOps, and then we'll see how it affects my Kubernetes cluster. So I'm going to go back to my GitHub repository, and I'm going to go to show you how it looks like. Traffic split. So here, as you can see, I have Bookstore, which is V1, Bookstore V2. V1 has 100% of the weight, so I should not have any traffic to V2. Let's see how this looks like in real life. So I'm just gonna scroll a little bit down and open the other Bookstore application. I'm just gonna move things around to be a little bit clear. And then I'm going to explain what I'm going to do right now. Okay. So what I have here is that this is a simple application. It's showing that it's incrementing books that are bought. Of course, that's just incrementing. If I sold those amount of books, I would not be here today. And I'm going to just show you from the Kubernetes side what's happening as well. So I'm just going to paste some code that I have. And you can see here that all of my all of the purchase or the transaction are happening on store 1. So on V1, and you see here in V2, nothing is being redirected. So let's jump back to GitHub. And what I'm going to do is that I'm going to change this, and I'm going to make this as 75-25. I need just 25% of the users to get the new interface and validate how it looks like before completely moving to V2. So as that happens, you're going to start seeing in the PowerShell prompt, you're going to start seeing V2 appear here. So you see there are some transactions that are starting to happen in V2, and you can see some customers are starting to buy from the V2 version of the application. And again, the numbers are not very accurate, but it's going to be 75-25. And again, I can change this later through GitOps and Open Service Mesh. So again, those are a couple of scenarios that shows you the power of what Azure Arc brings to your Kubernetes clusters. And again, all of this can be done through infrastructure as code, Terraform, Bicep, ARM. It's very easy to configure. And by the end of the slides, I'm going to show you how you can get the exact demo and do this for your customers or for yourselves. So hang tight in there. So let me go back to my slides. And before I switch to another topic, I don't see the chat. So does anyone have any question before I jump into another part of Azure Arc?
No, I think you're all good.
Yeah, I think you're good. Just checking now.
Okay, perfect. So the second part I'm going to talk about is data. So we've talked about applications. Now let's talk about what Arc brings to your data. So you're going to find this common across the slides that I talk about. So you're going to find the same type, any infrastructure anywhere. And the difference here now is we have another set of services that Azure Arc brings. And we have Arc-enabled SQL managed instance, Arc-enabled PostgreSQL, and Arc-enabled SQL Server. It's I forgot to add it here, and Arc-enabled machine learning. So what those services provide is that it allows you to take those past services from Azure and deploy them on any Kubernetes cluster that you have on-prem or in other clouds. So this is enabled by custom locations, as I've shared. So the main first step is to have an Arc-enabled Kubernetes cluster, and then you can take those services and deploy them on top of them anywhere. So in terms of Arc-enabled data services, again, there are two categories. You might have existing apps that are already running on SQL Server on Windows anywhere, and you don't want to modernize or move away. You'd like to keep using SQL Server, but maybe you're missing a couple of cloud goodness. So Arc-enabled SQL servers allow you to do so, and I'm going to talk about this in the next slide. But if you're thinking about app modernization, you'd like to move away from SQL and having to manage lots of clusters and takes ages to deploy it or upgrade it. You'd like to have a more modern way or a more managed way. Then you have two options: Arc-enabled SQL managed instance, which I'm going to demo today, and Arc-enabled Postgres. And both of them are managed solutions. So I'm going to explain what kind of features you would expect from both of them. So if we talk a second about SQL Server, you have SQL Server running on your Windows Server machines, again, anywhere. Once you onboard it to Azure Arc, you get a good set of features. Again, you get this ARM layer, you get this governance layer, you can query all your servers from like Azure Resource Graph, you can apply tags to your SQL servers and do the normal ARM stuff. But you can also get Defender for Cloud to protect your on-prem SQL server. You can get alerts and you can get recommendations for this SQL server. You can also get Azure Purview on top of that when you're using Azure Arc. And there are a couple of features that have been announced recently, which are best practice analysis solutions. So once you onboard that, you automatically get a BPA or a best practice assessment solution, which analyzes your SQL Server and then gives you recommendations against security, high availability, performance, query performance, and etc. So you get this on demand. So it's a very powerful, non-disruptive way to add value to your database administrators. And finally, you can also use Azure Arc to change the licensing of your SQL. So maybe you have a SQL Server that is going to be used for a specific project. It's not going to be forever, so it's a temporary project. You don't want to pay for the full SQL license. You can use Azure Arc to change the licensing to be pay as you go. So you can get cloud billing on-prem. Again, it's really useful for specific use cases, but it's very, very powerful. So if you have SQL Server that has a variable performance, or again, it's going to be used temporarily, you can use this to switch its pricing model, and you don't need to buy licenses or any subscriptions. So let's switch to Arc-enabled data services. So we talked about cloud native, and so one of the main challenges that I've started the presentation with is compliance. Maybe as a customer, you might have some databases that cannot live outside your premises. Hosting the data layer outside of your premises is simply off the table. So with Arc-enabled data services, it allows you to deploy Arc-enabled Arc SQL managed instance and Arc-enabled PostgreSQL to any Kubernetes cluster that you have. And this gives you a couple of features. It gives you an always up-to-date SQL instance. So again, since it's managed, you don't need to manage its patches. It's Microsoft manages this for you. And since it's built on top of Kubernetes, then it's very fast. And I'm going to show you an example of that. Automatic updates, downtime is very, very minimal. We have 2 SKUs of Arc-enabled SQL managed instance. The downtime is very minimal. Multi-layer security, there are lots of capabilities coming. For example, Azure Active Directory authentication. Now we have Azure AD DS authentication, so local domain controller authentication, but Azure AD is coming. You get elastic scale. So again, since it's on top of Kubernetes, it's just scaling up and down. It's just pods scaling up and down. So you have this elastic scale, and you pay for what you use. And of course, the biggest value is that deployment in seconds. So if you try to deploy SQL before, if you used SQL Server before, you know how long it takes to deploy and how long it takes to upgrade it. But in Arc-enabled SQL managed instance, instead of hours, it's just seconds and sometimes minutes in terms of bringing up a new SQL instance or upgrading it to a new version. So a couple of points. It has feature parity with SQL Server Enterprise. So it has high compatibility, so it's easy to migrate from SQL Server to SQL managed instance. It has built-in high availability, and it has you can configure readable secondary instances to empower your developers, and you have unlimited CPU and memory, and unlimited is within the scope of your Kubernetes cluster. So you can scale up as much as your Kubernetes cluster would allow you in terms of CPU, storage, and etc. So a couple of numbers just to show you how powerful SQL managed instance is. So there was an experiment that we've done on a Dell server, and to compare the performance of a normal SQL server and Arc-enabled SQL managed instance. And the numbers are staggering. So it's 15% faster. It took 60 seconds to deploy. So 60 seconds to deploy a fully highly available 3-replica SQL managed instance, and deploying the business critical high availability just 2 minutes in terms of deployment. And you can get similar numbers as it upgrades to a newer version. So the performance is just amazing. Your developers can just bootstrap the data layer, the SQL managed instance, with their applications using Terraform or ARM templates, and just have the full solution, the full stack deployed in a matter of minutes. Again, just a diagram to show you a high-level overview about the product. So again, you see this common layer of Arc-enabled Kubernetes cluster. This is what allows Azure Arc to deploy the PaaS services. And as I mentioned, you get Active Directory domain services integration. So, and I'm going to show this in the demo where I connect using the domain credentials instead of SQL credentials. In terms of the ARM or the Azure resources and services, not everything is yet supported. So Defender for Cloud is the obvious missing part, but Azure Monitor is there. You can deploy using ARM template, Terraform. Azure Active Directory is coming as well. So there are a lot of capabilities that you would get with that. To show you how the patching process have, so this is a 3-node highly available SQL managed instance. As you can see, it's totally built on Kubernetes, so it's all pods, and you can see that it automatically creates this availability group. So if you worked with SQL, this is not a new term. It's the same availability group technology that is available in SQL. And in this scenario, I have an unpatched instance. And as a new patch comes, what happens is that one node is taken out to be patched, and then it's once it's patched, then it comes back online, and then the secondary one gets patched, and etc. So the downtime is absolutely minimal, and you can configure maintenance windows so that you have full control on when this patch happened. You can have it automatic, or you can do it manually if you'd like. In terms of high availability, similarly to what you've seen in the upgrade process, if one node goes down, for example, you're going to find that if the primary node goes down, you're going to find that the traffic, there is an internal load balancer. The traffic is going to stop from going to this failed node, and then the engine is going to promote one of the secondaries to be primaries. And once this once this replica gets back up, it's going to be added as a primary replica until you decide to move it back to be the primary. So again, the high availability in the business critical SKU, it has near zero downtime. So it's very, very reliable. Another part is you can do disaster recovery. So you can have Kubernetes clusters in different locations, and you can configure SQL managed instance to be part of a distributed availability group, so that if one cluster goes down, you can fail over to another cluster in another location and have your applications functioning even if one site goes completely down. The last part before moving to the demo, just wanted to show you how the scaling. Again, it's just pods, so the scaling is very fast. And you can do this using Azure CLI or Azure Data Studio or even kubectl. And one of the things that I wanted to mention here is that you have 2 modes for Azure SQL Managed Instance. So some customers would like a completely offline mode. They do not need to connect to Azure, and this mode is supported. So you can take Azure SQL Managed Instance and just have it completely offline deployed in a submarine. It does not need any connection to Azure. You need every 30 days to upload some metrics for usage and billing. But in terms of the functioning of the solution itself, it can be completely offline. So with that said, let me jump quickly back to the Azure portal and let me show you how it looks like. So.
And quickly, Seif, I think there's a couple of questions from Sebastian in the chat around Arc-enabled SQL Server managed instances based on Kubernetes. Where and how is the data stored? Does it need specific storage classes, or how is that done?
Yeah, that's a great question. And the storage is through Kubernetes persistent volume. So there are guidance in the documentation on how to plan that. So it's your infrastructure, your resources. We're bringing Azure services on top of them. So you manage the storage there. We have some recommendations on the type of persistent volumes that you have, for example, for backup, for logs. But again, which storage that you use, it's totally up to you depending on your infrastructure.
Cool. And another quick one, if that's all right, on the Purview integration. So is that integrated in the Arc agent / pod, or do we need to use the self-hosted integration runtime additionally?
That's a good question. I don't have an immediate answer for it. If you can reach out to me, I can get the answer for you. But I assume since it's just an Azure service and Azure, the Arc agent does all of the communication. If we're talking about SQL Server, not Azure SQL Managed Instance, all of the communication with Azure is done through the agent. So I don't think there is any additional agents to deploy, but if you can just drop me an email or ping me on any of the channels, I'll try to get an answer for you.
Great, thanks.
Sure. Okay, so let me quickly jump to the Azure portal again. So here you see I have 3 instances, 3 Azure SQL managed instances. And if I jump to it, you're going to find that there is not much to manage. And that's a good thing because we asked for a managed service and this is what we get. So the only things that you can change is the number of replicas. So I'm deploying a business critical SKU. And I can deploy up to 3 replicas. Each replica has its own storage volumes. It has its own resources so that if one goes down, it does not affect the others. I can configure the number of secondary replicas. I can configure the resources that are assigned to this instance. And I can even apply Azure Hybrid benefit. So if I have software assurance and I have SQL Server licenses, I can use this here and get, I think, around 40 or more % discount on Azure Arc SQL Managed Instance. I can also enable Active Directory integration and upgrade management. So here I'm going to see if Microsoft releases a new version. I'm going to see it. I can have it applied automatically, or I can create a maintenance window so that it deploys maybe in the weekends or so. So this is all I can do from the portal. Everything is managed, as you can see. Jumping to show you how it looks like and how the experience is, it's just a SQL instance. So I can connect to it using any the same SQL management solution that I have. So I'm going to get the connection string, and I'm going to use the old good SQL Management Studio, and I'm going to use Windows authentication. So I have a domain controller, and this service joined the domain, and I can see my databases here as if it's a normal SQL database. So if I look at this database, I'm going to find that I have 4 records. It's 4 books that are for an app that I've built. So if I click on the app, I'm going to see those 4 books. And as you can see, it's a simple cloud native app, and I'm using SQL Managed Instance as my backend. So it's very powerful to have this sort of agility. And one of the cool things is that SQL Managed Instance comes with native Grafana integration. So Grafana is a very powerful open source visualization solution. So it automatically gets deployed with Azure Arc enabled SQL Managed Instance. So I'm going to show you a couple of built-in metrics. So here I can see the CPU usage, the RAM usage. I can see a lot of metrics. All of this I've not built. All of this is built out of the box as I deploy SQL Managed Instance. Okay. So let me jump back. And again, I'm going to show you at the end how to get this demo as I've shown it so that you can play with it. The last part that I'm going to talk about is Azure Arc enabled servers. So good old servers, Windows, Linux, virtual machines. I would like to, again, I'm using Azure. I'm deploying virtual machines. I'm using Defender. I'm using Azure Monitor. I'm using automation accounts maybe to do change tracking or inventorying software on my servers. I'm using Azure Update Management to patch my servers and etc. A lot of features, and I would like to get some of those on premises or in other clouds. So with Azure Arc, I can do this. I can just install a simple agent on my Windows and Linux machines, connect my servers to Azure Arc, and get this full set of capabilities. So I'm going to skip this slide. I'm going to show you in the demo. I'm just conscious of the time that I have. And this is, again, the diagram. So again, you know Kubernetes here, just Windows and Linux servers. And you can see the whole set of capabilities that are available here. Let me just jump a little bit faster. Yeah, let me jump to the demo. It will make more sense to show it. Going back to my Azure portal, you see here I have some servers that are connected to Azure Arc. I'm going to select one of them, and you're going to find a very familiar experience if you've worked with Azure virtual machines. It resembles an Azure virtual machine. So I get my tags applied here. I get some information about the operating system, the version, etc., etc., and I can get Defender for Cloud recommendations on my server. So as you can see, I have some vulnerabilities on my servers. And through Defender, I can even deploy a vulnerability assessment solution on my on-prem servers or on my AWS servers and get those vulnerabilities reported here, and I can act upon them. So here I get all of the recommendations. I can get real-time security alerts. I can also monitor my servers from Azure Monitor as I monitor my normal Azure virtual machine. So again, all of this is out of the box. I've not created any of this. I just onboarded to Azure Monitor using a policy. So I apply a policy to a resource group, and any Azure Arc server that gets onboarded automatically has the new Azure Monitor agent, and they get onboarded to this solution. So it's very seamless to get that. And of course, I get inventory and change tracking if I'd like to query all my estate for a specific executable. Maybe there is a malicious software that gets downloaded in my organization. I'm using servers in AWS and on premises. I can just simply here go to Log Analytics and run a query to find me this executable on all my virtual machines, regardless where they are, and I automatically get this where this software is available, and I can just maybe run an automation to uninstall it or delete it. So it's very, very powerful to do this at scale. So lots of other capabilities. Again, Azure policies, we've talked about it. Patch management. So a lot of customers would like to have a centralized way to patch their servers and have all of the reports in one place. So Azure Update Center is the new way to do so. So I can onboard my Arc servers and start patching them through here. I know I have just 3 minutes, so the last thing that I wanted to share is I mentioned at the beginning that I'm part of a team called the Azure Arc Jumpstart team, and what we do is simply help you get started. So a quick intro about the Jumpstart team. It's a portal. I'm going to show it to you. It's a publicly available website. It allows you to have this supermarket experience. So anything that you'd like to learn about Azure Arc, you're going to find it there. If you want to learn how to onboard AWS EC2 instances to Azure Arc, you're going to find automation. You're going to find step-by-step guidance on how to do so. If you'd like to deploy Azure Arc SQL managed instance on an OpenShift Red Hat cluster, there you're going to find automation and step-by-step guide on how to do this. And finally, we have something called ArcBox and HCI Box, which are sandbox environments that build a complete Azure Arc environment with onboarding, with Defender, with Monitor, and all of the demos that I've just shown you are based on ArcBox. So if you'd like to do like the traffic split demo or the GitOps demo, just go deploy ArcBox and you're going to get the exact same experience, the exact same apps, and step-by-step on how to perform the demos that I've just shown. Of course, we have a YouTube channel to talk a lot about Arc and different innovation there, so definitely check that out. And the main solution we have is ArcBox. So ArcBox is the sandbox environment that you just seen. It has different flavors. So full deploys absolutely everything: Arc-enabled Kubernetes, data services, servers. We have ArcBox for IT pros. If you just your focus is just Windows, Linux servers, and SQL Server, then definitely deploy it. It's much lightweight than the full. If your focus is on Arc-enabled Kubernetes, deploy the DevOps one. If your focus is data, deploy the DataOps. So this is just an architecture of the full edition. This is what you get as you deploy it. You can deploy it through Portal, through ARM, through Bicep, through Terraform, whatever you're comfortable with. And this is what you get. So just one click, you get all of this configured for you. IT pros, again, it's much lighter, focusing just on servers. DevOps, this is what you've seen with Open Service Mesh, Key Vault, and GitOps, and you get 2 clusters. And DataOps is the final demo that I've shown for Azure Arc-enabled SQL managed instance. So all of this you can get with a click of a button with scenarios that you can go through. We also introduced recently HCI box. So if you're interested on doing so on Azure Stack HCI, we provide this where you deploy HCI box and you get Arc-enabled AKS, Arc-enabled AKS. You get GitOps, you get data services, you get lots of different capabilities, but on HCI. Quickly to show you how it looks like, I'm just gonna switch very quickly to the portal, to aka.ms Azure Arc Jumpstart. And here you're going to find the scenarios that I was talking about. So you're going to find all of the Azure Arc services. So if you're interested, for example, in just Kubernetes, you're going to find Kubernetes, you're going to find a scenario on AKS, on Stack HCI, Azure Red Hat OpenShift, AWS. And if I click on AWS, you're going to find step-by-step on how to use Terraform to deploy an EKS cluster on AWS and onboard it to Arc, and then get all of the capabilities that I've just shown you. And the automation is available on GitHub. So again, definitely check Jumpstart. If you're interested in Arc, you're going to almost find 99% of what you need available on this project. With that said, this is where you would get to the Jumpstart. There are some learning paths that can help you to get started. And yeah, thank you for that. I know I've rushed a little bit, but this is all I wanted to share with you today. So if you have any question, please reach out to me on Twitter, on LinkedIn, and I'll be more than happy to help you with that.
No, that was fantastic. Thanks so much, Seif, for taking us through that. Yeah, I certainly learned a lot today. So yeah, and not sure that there's any additional questions in the chat, but if anybody's got any comments or chat questions, put them in the chat. Apart from that, yeah, show your appreciation for Seif. Thanks so much for joining us, Seif.
Yeah, thank you very much. Mind-blowing.
It is. There's so much you can do with Arc, isn't there? I mean, in terms of all the different ways you can deploy it. So
Definitely.
Awesome stuff. Yeah, feel free to stick around, Seif, if you've got time for our quiz, but we'll hastily move along straight into the quiz then. So Matt, over to you.
Let's do that. What are we gonna do? Top 1 tonight? As this is not me.
Yeah, we'll do first place for an Amazon voucher, £25 Amazon voucher, is it?
There we go. Yeah, everyone should be able to see that one now. I'll go for that one.
Join on the phone, I think.
There we go. Good.
I'm in. Who else we got? Any others join in? We got a good, yeah. Let us know if anybody's struggling. Message in the chat or come off mute.
Excellent. That's good.
There we are. They're all coming in now. Who else we're waiting on? Alan, you in yet? Ahmed. See Graham there. Mark, I don't know if you're joining.
I don't know. I've got a waiting for players to join message.
You always seem
No,
Oh,
I
yeah,
know,
yeah, that's-
I'll tell you later what the other problem was.
Yeah, I'm on like the loading spinner for waiting for players to join.
Can you see your name on the screen?
No.
I've got a name and it says waiting for players to join. Your host will start shortly.
If you
I'm gonna try again.
yeah, just do a refresh on the page.
I've got that page as well, but I can see my name on there. So,
Yeah.
or just try and go to that URL and type in the code, I guess.
I can see my name.
Ah, there we go.
Oh, there we are.
Interesting.
Any more, Ahmed? Are you still struggling to get on?
I seem to be, yeah. Come on,
You're not
interwebs, you
eligible
can do
anyway,
it.
mate.
Say that again.
You're not eligible anyway.
It's very true, but I just want to play along.
I don't know why it's not letting you in. We might. We'll have a look through the logs later.
Maybe it knows I'm not eligible.
Oh, we've got someone else in.
We've got somebody with a blank name. That's going to be difficult to know who that is. Yeah, Wolfgang's aren't.
Should we try with that? I think that's probably everyone excluding me.
Yeah, well, we've got 9. Yeah, that's about right, isn't it?
Let's see
So
what happens.
Who is the blank one? That must be you, Ahmed.
Oh yeah, it must be. I'm Billy No Name.
Right then, here we go. What is now required for all developers who contribute code to GitHub? Is it a black polo neck shirt, 2-factor auth, a clicky keyboard, or a Mastodon account?
Oh, God.
The top one, I think, is a requirement for working at Apple. My camera frozen, or was it just me?
Clicky
The
keyboard.
answer was 2-factor auth. Well done. What was added to the Azure OpenAI service this month? Many people thought it was already there. I'm not even sure which version it is, which might be a bit of a giveaway. ChatGPT, yeah. Majority of you getting that one right. Bing passed a daily active user milestone this month. What was it? Was it 100 million? Was it 20 million? Was it 250 million? Or was it a person outside Microsoft? It was 100 million. Oh, that split the pack.
Being too generous, I was.
What does the A stand for in KEDA? The automatic auto-scaling Azure or abstract. That's a tricky one, that is. Unless you were paying attention to Wolfgang's presentation, where he did actually mention it. Auto-scaling. Majority of you were paying attention. Well done. Which of the following is not a scalar in KEDA? Another tricky one. And if you joined the chat right at the start, we were talking about one of them. The answer is event grid.
Boom.
And usually all the others. You were the one, were you, John? Well done.
It was a guess.
And this was also mentioned in which year was the 1.0 version of KEDA first released?
Isn't it the year John was born?
It was 2019. Well done, all. Which of the following is not a place Azure Arc can be run? Kubernetes cluster, VMware vSphere, Azure Stack HCI, or Azure Functions? Oh no!
Oh,
Oh no,
Oh no! We've had a
an
failure
unhandled error.
after a year. This is the first time in a year. I think we might just have to randomize this one, John. 'Cause I don't think that's going to work. If I do that, I think it's going to reset it back. Oh no! Oh well, that's a bad state of affairs. I think we might just have to randomly pick someone, John.
Go on, you can do it then, Matt.
Oh.
Right, first person. Oh, go on.
Let's go. Alan.
There we are. That was an easy win, was it? Alan
That's the
Florence.
fairest way I can do that. I'm going to have to go and investigate now. That's my night gone now. Trying to work out what went on there.
Right, you can write all your letters of complaint to Matthew Dotford.
That's bad. After a year of working.
An unhandled
it's failed.
exception has occurred. Error has occurred. Reload.
Yeah, I know. Yeah. Thanks for joining as well.
Yeah, current players. That's an apt face, that is as well, isn't it? That's an apt one.
Yeah.
Question for you: could it be because there was some short or blank usernames in
Yeah,
there?
may well be. I'm raising an issue for that one straight away. Well,
Right.
apologies for that, everyone.
No, what
That's
it was
all
going to
right.
happen one day, Matt. You know, we can't have such an
If
easy
we've had a-
ride with a completely
Yeah.
developed quiz platform. But cool. Okay, congrats, Alan. Yeah, just do me a favor, drop me a message on one of the socials just for my little
Okay.
brain, so it.
I can tell you what happened last time. By the way, I got to the bottom of it.
Oh, I.
Oh, for the problem on the.
Yeah, and Matthew was not far off being correct, but for the wrong reasons. So I discovered that somebody had hoovered up all of my bandwidth.
Yeah.
Yes. I'm like, you said, oh, well, it might be because you're VPN or whatever. And I'm thinking, no, I've got tons of bandwidth.
Yeah.
So I went on a scouting mission afterwards, and I discovered that somebody had indeed evacuated all my internet connectivity. I was not impressed.
It's
Reclaim.
actually a bit of a challenge with the way that quiz has been written, in that because it uses a technology called WebAssembly. It means that there's actually quite a large initial download.
You know, when you put that loading message up, is that you doing it or the? Yeah.
Oh, yeah, that's me doing it.
Right. So my thoughts were just put loading, please wait, because the package you'll download is, you know what I mean?
Yeah, I've got some control over that. So yeah. All right, I shall add it to the backlog.
Is it done in what's it called?
Blazor.
Yeah.
In fact, actually, if you go back through our archives on the YouTube channel back March last year, there's the talk I did on it.
Okay.
And I'm happy to. I'm always happy to talk about that, to be honest.
No, I'm not. Obviously, it's fair. I'm not a developer guy, but I like to know what people are using, how and why and stuff.
Yeah. No,
It's due an update talk, surely soon, Matt. That's
yeah. There's some stuff I want to add to it first, but actually, it'd be nice to get the lady that did the UX design work on it, because she did a cracking job on.
Cool, hokey doke. Well,
to be honest,
we wrap this
I've
one
got
up then?
enough videos and talks and things that I need to look after. There aren't enough hours in the day at the minute.
Oh, tell us about it.
We all know that problem.
Right, okie doke. Right, let's wrap this one up then, see if we can get away on time. It's 8:30 now. So yeah, look, thank you everybody for joining. Big shout out to our speakers, Wolfgang and Seif. You know, huge appreciation for the guys coming on. You know, especially Wolfgang. How you're still up, I have no idea. Clearly, you do work at European hours. So,
he lives in Perth, so they work at the opposite end of the Australian spectrum because they know they have to communicate with people from the UK.
There we go. There we go. Well, there we go. That's not a bad place to move then, is it? You know. Anyway, yeah.
My partner moved back from Perth not so long ago. That's where she expected to spend the rest of her life, but she was forced to come back to the UK.
All right, there we go. Well, there we are then. But cool. Okay, yeah. But big shout out, Wolfgang, Seif. Really appreciate the talks tonight. Really interesting and educating. So thank you very much for that. Yeah, if you get a chance, please do leave us a little bit of feedback on the session tonight. We'll ignore the quizzer the way the quizzer ended tonight. So no feedback needed. Just raise your issues on GitHub, eh, Matt?
Yeah, absolutely. I'm looking at the logs now.
Save the date for the next meetup, 19th of April. Just getting a few things finalised for the speakers for that event. Will be virtual again. Yeah, save the date. Go on the meetup, RSVP now if you like. Other than that, great to see you all again. Thanks for joining, and yeah, hope to see you all next month. See you all soon.
Thanks all.
Thank you very much.
Take care, chaps. All the
Take care.
best.
Bye bye.
Bye-bye.
Good night, all.
Cheers
Bye.
all. Ta-da, bye.
Bye-bye.